Hi, my name is
Hello.
Oksana. Yeah.
So
So,
let me introduce
yeah,
the first speaker is
sorry.
Oksana Shadura. Uh, she works as a software engineer at the University of Nebraska-Lincoln and also is working at CERN at the moment. And the first talk will be around challenging designing interactive analysis facilities with Dask, hooking up Dask, JupyterHub, and HPC. Go ahead.
Thanks. So yeah, I would like to present a work. Basically, it's not only me was working on this, but a team of the people and a lot of people also. I probably didn't reference them in this slide, so it's a big team of the people involved. I'm not sure if you are familiar with high energy physics. I just wanted to start with some kind of, quick introduction. So as you all know, Large Hadron Collider is one of the biggest and probably the most powerful particle accelerator that was built. And as well, it's kind of the largest scientific instrument, as you can imagine. Yeah, it's located next to the Geneva. Basically in 4 points, we have like 4 detectors where in these places, the beam is kind of crossed. So we can actually record our interested events, like physics events. And then physicists will try to analyze data that was collected against the theory that was kind of predicted to be. And when you see some kind of discrepancy, like you see here a red peak, it's basically what was meaning like discovery of boson Higgs in this case. Oops. Yeah. How actually the typical, let's say, day or week of the physicist looks like? So at the beginning, of course, before physicists will start to work on the data analysis, we need to collect data from the detectors, as I already told. And here it's not very simple because at the end, these detectors, they have kind of onion-like structure where you can record the interesting events for you. For example, to measure trajectory of the particle, or you can measure the mass, you can measure the energy, and etc. In the same time, there is a simulated Monte Carlo simulation, and all this all the data is stored in data storage. Data is stored usually in specific data format, root format, and it's very interesting because a lot of high energy physics data is basically stored in this particular format. And for the format specification, you can check out the webpage. So what then happening when the physicist can finally do the analysis? He or she needs to follow a lot of stages. For example, start to create a model, a signal model, apply data selection, create a background model, fit model to the data, and then check physics results. And sometimes this iteration could take multiple times. So it's very time consuming and very hard, like computationally procedure. So we would like actually to improve it because, yeah, at the end of all this procedure, then finally the results could be published in some paper, journal, and etc. The new issue that we are the new problem that we are reaching out now is that, as you see on this plot, in 2010, basically when LHC was started to collect data, we calculate our the interesting events that we would like to measure for statistics. It calls like integrated luminosity. Basically, it's very proportional to data ratio. And you see where we are now. it's not that bad situation. But in 10 years, we expected to move to called high luminosity LHC era, where we actually will collect much more significantly, much more data. So our goal actually to try to, if we can do it now, to make a simpler, more agile paradigm for analysis today. But the problem is that the scale that we saw of data is actually adds more complexity. So for you to maybe imagine more better numbers, what is happening with data is that when was a discovery of boson Higgs in 2012, and comparing to this high Lumi LHC era, we will expect to collect 10 times more data, basically exabyte each year for 2 experiments. An exabyte, for example, just to imagine quickly, it's like a Zoom meeting that lasts 100,000 years. What we do with all this data, how we process it, where we store it. Well, we organize kind of like a network, a grid of 170 computational centers in more than 40 countries, which are linked with the network and provides distributed storages. It looks like a bit like an onion structure. So we start with the CERN one, which is tier 0 in the center. And then each layer is kind of different level of responsibilities of different centers. For example, tier 1 is responsible for permanent storage of the data that we collect or reprocessing. Tier 2 on the blue level on the third is already simulation, where is running end user analysis. The problem is actually that currently it's not very much user friendly, so it requires a lot of, let's say, SSHing to terminals, trying to so it's really not how you imagine like running something in Jupyter notebook or something like this. Yeah, and as well, since many years, we actually using a special data access protocol called XRD. I will not go into details about it because it's, as you see, it's very modular, plugin-like architecture with a lot of different options and possibilities, but it's also one of the kind of possibilities for us to access data, but sometimes it's actually could be a bottleneck. What we were looking for the new ideas for analysis facilities, for the place where physicists will be doing the analysis. First thing, we would like to investigate new Pythonic ecosystem, because initially we were more like high energy physics is more C++ based historically. Then discover column-oriented columnar data analysis. So we'll talk a bit about this later. And according to feedback of the users, we understood that users are very interested in interactivity. So they would like to have as quick as possible access to the preliminary plots, or to investigate interactively their data. Other thing, as you saw, because of the data issues, we would like to deliver needed data to processing workflow in fine-grained approach, basically through, we call it data delivery services. And we're trying to investigate now like different storage technologies, efficient one, try to integrate in our frameworks, like for example, object stores. Kubernetes and as well a new concept for us, infrastructure as a code helping a lot, because we can kind of expect that our analysis facility could be portable, and we can install them across different environments and easily maintainable by administrators. And the main problem is that since we already have a lot of resources available for data analysis, we need to integrate these new concept, this analysis facility, with the existing resources, because we understand that current infrastructure is not going to be replaced in one day. During last years, we started to actually investigate a lot new, as I told, new Pythonic ecosystem and build on the top our like high energy physics. There is a lot of interesting packages that I will probably not go through because it will take me either 30 minutes. But I would like to invite you to today later to listen talk of Nicholas Smith, who wrote actually one of developers, main developers of Coffee Framework, which you see in the center. And actually he investigated how to add Dask executor there and as a distributing processing. Sorry. Okay. Interesting. Fine. We are missing here yeah. So I wanted to give a brief introduction about Coffee Analysis Framework, and and talk a bit more about columnar data analysis concept. So traditionally, here on the image that you don't see, traditionally our analysis was operating row-wise. So if you can imagine a table in row-wise, was corresponding to reconstructed particle collision events. Now we're trying to move to columnar, where we we manipulate on individual columns of data and trying to use array programming for this. The nice part of Coffee is that users just need to define the high-level wrapper around his analysis code, and it calls Coffee processor, and then Coffee framework will take care of everything, including scaling. It supports also distributed executors, Spark, Parcel, and Dask. And yeah, finally, I would like to talk a bit more actually what we try to do in this analysis facility. So we try to bridge Kubernetes resources with our University of Nebraska-Lincoln tier 2 resources. This one of biggest grid computing centers, as I remember I was explaining you, while trying to provide interactive environment. How it works, user is connecting through the browser to Jupyter Notebook, which is basically started with through the 8-core CMS analysis pod created on login, where we have already Dask scheduler container running, and as well Dask worker sidecar container, so running through Kubernetes resources. And then we can easily scale to already available HTCondor slots on existing computer center. We also, the other part to mention, we integrated the access, data access inside the Kubernetes cluster, and we're working on integration of data delivery service. So basically all this infrastructure will be connected together. Interesting points what we developed we have authentication inside the system is independent of grid credentials. So we just use OIDC for the connection, and then also we enable token authentication for Condor. So we generate tokens when user is kind of starting their notebook. It's done through the pod customization hook. We generate data access token, and also we generate credentials for the to use in Dask for TLS, as well like for user communication to Dask scheduler endpoint. For example, if the user wants to run through the Python session. on their laptop or whatever. So we by default, we have always TLS enabled communication. And we have highly customized, like for our personal purposes, for physics purposes, Docker containers. And all these features are incorporated in the Helm chart. So we can kind of distribute it to other places, like, and try to, in fact, we are trying now to install Coffee Casa facility in other places who is interested. About security, as I already told, we have TLS enabled communication. We expose scheduler to internet to allow users to connect directly to Dask scheduler from Python session. Since Dask use TLS, we'll kind of leverage SNI uniquely to identify hostname. Yeah, it's more about like, so we're trying to use TLS proxy Traefik to route request from outside cluster to correct Dask cluster. And in such a way, it allows us for all our Dask clusters in analysis facility in Coffee Casa to share the same IP address and port instead of unique IP per Dask scheduler. So it's really simplify the setting, in this case, the setup of analysis facility. Then we, to handle customization, which we needed for like our own purposes, for high energy physics, for all these tokens and etc., we developed our own Coffee Casa cluster object, the extension of dask-jobqueue HTCondor cluster. And then this allows us to ensure that Dask worker starts with appropriate Docker container that we selected with a particular HTCondor batch system with its configurations and firewall ports configured correctly. For the data access, we try to investigate some caching mechanism, like which are available for XRD protocol. And we have like our own caching, proxy caching service with 90 terabyte of cache space. So it's also interesting because usually a user which is using the typical running typical analysis, it will require to have special credentials and etc. In this case, for user, everything is transparent. So again, there is a token which is generated, and we can easily authenticate with this proxy service. And then, of course, after proxy service already communicate via usual credentials. I just want to show like very quickly how looks like simple user example. This is like we call it benchmark or something, where we just try to plot event level variable, in this case Matt. And here you see here how it looks like a coffee processor that I was talking before. And then at the end, we just connect to a client. This is how looks like our file set. If you were curious how looks the way how we access files and XRD protocol and etc. And then we try to run a job using our Dask executor that Nick will explain a bit later in details. I don't want to steal his stage. Yeah, and for users, it's transparently available HTCondor cluster mixed. So we have part of resources from Kubernetes and part of resources directly accessed through the local batch queue, and user can immediately start to do computations. The interesting part, we start to invite our first users, and it's mostly, I think it's pretty successful because we have some analysis done by undergrad students, which means that it is very approachable. and interactive. So they're like happy with this. Yeah. The other interesting part that I would like maybe to stop a bit is about data delivery services. So we would like to, since the space that, as you saw, we don't have so much space available for the new data and etc. We would like to have a possibility for users to have their own, to create their own custom data sets and convert these data sets into required columns. So basically have column on demand service. And there is already development, and each of what we are, of course, it's more part of Coffee, because Coffee's framework that Nick will be talking later is incorporating all these features inside. But in the same time, we're trying to check that everything is tested with Dask. Then also we have very interesting development called Skyhook. It's basically allowing us to have extension of Ceph to have transition on disk from on disk format to any desired memory format. And it's also used Dask workers to distribute data. It's more like low level. It's if you would like, yeah, please Google, it's super interesting. And there is also column service. It's development by Coffee team about multi-tenant service for caching columnar data that basically improves it gives possibility not to rerun again and again expensive algorithms. Now a bit about challenges, what we actually, since we're just starting, so it's really, you know, the beginning of our discovery. And we probably will contact you a lot and ping Dask community about what to do. But I just wanted to share what we noticed and what's something that users is starting to report to us. So first thing is that with the dask-jobqueue, as you know, we scale to local HTCondor job queue, but apparently we noticed that CLI arguments for Dask worker are probably not properly generated. At least we have an incorrect contact address and listen address. So we are having like a special post-build hook that allowing to pass as correct arguments. Then also we noticed, since we are heavily relying on the feature of Dask Labextention, we thought to try to make the job submission async. Maybe I'm not sure. I still need to investigate a bit more and collect some feedback, but we see some glitches here and there. Also, sometimes we see like workers are dying. Not sure why. Exception while handling heartbeat worker. So again, I will try to ping you. I know that you have already the Dask Helm chart, and it probably will be a very interesting solution for us to use Dask Hub from it. So we need to investigate Dask Gateway, because we were mostly using Dask Labextention powered cluster with this custom coffee casa object. And yeah, we have our own Helm chart, and it's based on as well 0 to JupyterHub. Yeah, so we will take a look, and maybe, yeah, we will switch, not sure. And as well, the same thing, I know that you have specifically like targeted to community Docker images, similar to Jupyter-based notebook. We have our own, because we have a lot of custom settings, and also we are trying to integrate, let's say, the release procedure together with, for example, Coffee. So they are releasing in the different Docker image, and we are trying to follow it up. Yeah, as I already told, we noticed, for example, for Dask Labextention, There is sometimes some glitches, and we will happy to report issues or try to contribute fixes as well as much as we can. And we noticed that, for example, autoscaling in dask-jobqueue require a bit of tuning. It doesn't really evaluate properly needed amount of workers. So definitely we will investigate it and try to bring back to you our experience. And we still have some patches um, mm, that we are using in analysis facility, and I think I will try to refresh PRs that were opened by Brian to see if we could lend them, because maybe they could benefit community. Yep. Thank you so much. Yeah.
Thank you very much. And we have time for maybe a couple of questions. One question in the Q&A tab, and other people, please do feel free to add them as we talk. The question is, with the Dask scheduler exposed to the internet, how do you ensure that only legitimate users can submit tasks?
Yeah, it's actually a good point. So from the point of view, how it works currently for us is we have before to log into JupyterHub. We have actually the OIDC authentication, which is not really simply, it's very complex based on actually eligibility of user to log into to analysis facility, because it belongs to particular university group, experiment, and etc. So this is from the point of view if we go through the browser. But in the same time, we are just experimenting on the side of, because some users would like not to use Jupyter notebooks, but they would like to have access from their favorite terminals. So in this case, we know that they could download their certificates. This was the initial idea that we are thinking, just accessing, legitimately passing all the authentication procedure. And then, of course, yeah, then we will need to think about if it is enough secure or not.
Okay, thank you very much. Seeing no immediate questions, we will finish there. And a reminder, people can continue the conversation in Slack and elsewhere.